Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on this video, I'd like to ask you to please hit the subscribe button, give this video a thumbs up, and engage with a comment below. Let's get started. In today's video, we're looking at Unit 1, Constructions and Rigid Transformations, Lesson 9, Speedy Delivery. This is actually the last lesson before the mid-Unit 1 test. The learning goal in this lesson is to use perpendicular bisectors. There are 2 learning targets in this lesson. Once we get done with the practice problems, we'll come back, review these learning targets, and ensure you understand everything you need to before taking that mid-Unit 1 test. The first learning target says I can construct perpendicular bisectors to help solve problems. Learning target number 2 says I can use my geometry knowledge to solve problems. For glossary terms, we're going to start with angle bisector. A line through the vertex of an angle that divides it into 2 equal angles. So if we were to estimate that this was an 80-degree angle, then the angle bisector is dividing the 80-degree angle into 2 40-degree angles. Next glossary term is circle. A circle is the collection of all points that are the same distance from a center point. The distance between that center point and any point on the circle is called the radius. The next term we have is conjecture. This is a reasonable guess that you are now trying to prove either true or false. Next, we have inscribed. At the bottom, you can see 2 examples. The example on the left, we would say that is a polygon inscribed inside a circle because it completely fits inside the circle and every vertex or corner of the polygon touches the circle. On the right side, you've got the opposite. We would say this is a circle inscribed inside a polygon because it fits inside the polygon and every side of the polygon touches the circle in exactly 1 point. Our next term is line segment. As opposed to a line, which goes on to infinity in both directions, a line segment is defined by 2 endpoints and only consists of all the points connecting those 2 endpoints. It does not count anything beyond those endpoints. Next, we have parallel. When we say that lines are parallel, it is because they will never intersect. They can go on to infinity in both directions. They will never touch. They will never cross. They are going to run side by side in both directions forever. If you have 2 parallel lines, then you could take line segments and say that those line segments are then parallel as well. Next, we have perpendicular bisector. This is the one we're really going to concentrate on today. A perpendicular bisector cuts a line segment exactly in half, and it does so at a 90-degree angle. So in the example here, everything on the right side of that dashed line would be closer to point B. Everything on the left side of that dashed line would be closer to A, and every point on the dashed line is the exact same distance from both points. Next, we've got regular polygon. The key here is that word regular. Anytime we're referring to a regular polygon, it means every side is congruent, which means the same length, and every angle is also congruent, which means it is the same angle. And our last glossary term, which is a new one that we've not seen before, this is tessellation, an arrangement of figures that covers the entire plane without gaps or overlaps. So some common ones you may understand, something like a soccer ball, where we have two different shapes that are mixed together so that you cover the entire surface of the ball without having any gaps or overlaps. Something like tile in housing. So tile in a shower, tile as the backsplash in a kitchen, behind the sink, around the cupboards. You're going to see a lot of these tessellations, which means they take a couple of different figures. So on the left, we have a smaller square and a bigger square, and they're arranged in a pattern where it doesn't leave any gaps or overlaps. And then on the right side, we have small squares and we have octagons, and they're arranged in a way that doesn't leave any gaps and doesn't have any overlaps. Now that we're done with the introduction, how about we go look at those practice problems? So let's begin the practice problems for lesson 9. Practice problem number 1, which construction can be used to determine whether point C is closer to point A or point B? So what we're going to do is we're just going to pretend we've got like a point A and a point B, and then we've got this random point C up here. So the first option is that we construct a triangle ABC. Okay, well, if I go ahead and I draw this triangle ABC, this doesn't really tell me anything about whether this point is closer to A or B. I just have a random triangle that's not really giving me any information. So A would not be the correct answer. So let's try it out with B. We've got that point A. We've got that point B. And then we've got this random point C. Construct a line perpendicular to segment AB through point C. So let's draw line segment AB. Then let's draw that perpendicular bisector. Now, this looks as though it's probably closer to point B, but it doesn't really tell us for sure. If this point C was a little bit closer to the middle, it would be even harder to tell. So this doesn't really tell us for sure which point it's closer to. So let's look at C. We've got our point A. We've got our point B. And we've got our point C. This one tells us to construct the bisector of angle ACB. Well, what that means is that we're going to take and draw ACB. Since C is in the middle here, then C is the vertex on our angle. Now we're going to come up with the angle bisector that cuts it in half, something like this. But again, this doesn't really tell us which point C is closer to. So it's not option C. Now let's take a look at D. I've got my point A. I've got my point B. I've got my point C. We're going to construct the perpendicular bisector of segment AB. So we're going to draw segment AB. We're going to find the halfway point, and we're going to draw the perpendicular bisector. Once we draw that perpendicular bisector, then everything on the left that I'm highlighting in blue is going to be closer to A. Everything I'm highlighting in green on the right is closer to B. And then anything actually on the line itself, which I will highlight yellow, anything on the perpendicular bisector is going to be exactly the same distance from both of them. So in this case, this tells us that point C is definitely closer to B because it's on that side of the perpendicular bisector. So D would be the correct construction to use if you want to know if a third point is closer to point A or point B, because the perpendicular bisector, by definition, divides the line segment in half at a 90-degree angle. I hope this makes it clear for you, but if you have any questions, feel free to always leave a comment below. Practice problem number 2. The diagram is a straight edge and compass construction. Lines L, M, and N are the perpendicular bisectors of the sides of triangle ABC. Select all the true statements. Choice A. Point E is closer to point A than it is to point C. So if we are comparing point A and point C, then that means line L is the perpendicular bisector. So anything in this blue shaded region is going to be closer to point A. And then anything below line L in this green shaded area is going to be closer to point C. So then when we look at point E, we can see that point E is shaded in green. And since it's shaded in green, that means it's closer to point C than A. That means A is incorrect. Now, let's take a look at B. Point L is closer to point B than it is to point A. So if we're comparing points B and A, then line N is the perpendicular bisector. So everything above it that I'm shading in blue is going to be closer to point A. Everything below it that I'm shading in green is going to be closer to point B. So we're talking about point L. Point L is right here in the green shaded region. And the green shaded region is closer to point B. So that means option B is correct. So that's one of our correct answers. Let's look at option C. Point D is closer to point B than it is to point C. Well, if we're comparing point B and C, then that means line M is the perpendicular bisector. So everything to the right of it is going to be shaded blue, and that is going to be closer to C. Everything to the left of it is going to get shaded green, and all of this would be closer to point B. So we're talking about D, and D is actually directly on the perpendicular bisector. Because it's on the perpendicular bisector, it is the same distance. From B and C. So that means option C is not correct. Now, our next choices are all going to compare a fourth point with points A, B, and C. So what we need to look at is anything that is above line L is closer to A than it is C. And anything above line N is closer to A than it is B. So this top part of the triangle, I'm going to shade in blue. And anything in the blue is going to be closer to point A. Next, anything below line N is closer to B than A, and anything to the left of line M is closer to B than C. So I'm going to shade this region in green, and anything in green is closer to B than it is A or C. And now, anything below line L is closer to C than A, and anything to the right of line M is closer to C than B. So I'm going to color this area in yellow. And everything in yellow is closer to C. Now let's look at the questions. D says point J, which is directly in the middle, is closer to point A than it is to point B or C. Point J is directly in the middle. Of A, B, and C. Therefore, D is wrong. It's the same distance from all 3 points. Option E, point K, which we can see right over here in the yellow area, is closer to point C than it is A or B. K is in the yellow shaded region. I said that the yellow shaded region was closer to point C, so E is correct. And our last option, point L, is closer to point C than A or B. So let's go up and find point L. And we can see that point L is right here in the green shaded region. That means it's actually closer to point B. Than it is A or C. So F is wrong. So the main point of this whole practice problem is for you to understand these perpendicular bisectors are cutting a line segment directly in half at a 90-degree angle. Therefore, everything on one side of the perpendicular bisector is closer to that side's point, Everything on the other side of the perpendicular bisector is located to is closer to that side's point, and anything directly on the perpendicular bisector is the same distance from both. I hope this has made this clear for you, but like always, if you still have questions, please feel free to leave a comment below. Practice problem number 3. Decompose the figure into regions that are closest to each vertex. Explain or show your reasoning. So, just a reminder, when they say vertex, they mean the corner points. So we're talking about A, B, C, and D. Now, the shape they have given us is a diamond. This is a polygon that is created with 2 equilateral triangles. So what we're going to do is we're going to draw a bunch of perpendicular bisectors. If I want to know whether something is closer to C or B, then I can draw a perpendicular bisector going from A to D. And now anything above and to the left is closer to C. Anything down and to the right is closer to B. The line segment CB is actually dividing things between D and A. Now, the next thing I need to know is when things are closer to C or A. So I'm going to draw a perpendicular bisector here. It's going to go from halfway between C and A down to point B. So I'm just going to draw this perpendicular bisector. Then I'm going to do the same thing to separate A and B. This perpendicular bisector is going to go from point C to halfway between A and B. Now I'll do the same thing on this bottom left triangle. I want to separate D and B, so I'm going to go from point C down to halfway between B and D and make this a perpendicular bisector. Then I'm going to divide C and D, so it goes from B through the middle to the halfway point between C and D. So now I have all my perpendicular bisectors. Now I just have to shade in what goes with what. So, for point A, I'm going to shade in blue. Anything above this perpendicular bisector going from point C down to halfway between A and B is closer to A than it is B. But then I have this perpendicular bisector between C and A that goes down to B. So anything on the right side is closer to A, anything on the left side is closer to C. So the region that's actually closer to A, I'm going to highlight in blue right here. So that's our first region. Now I can do the same kind of thing down here with D. If it's on the left of this bisector between D and B going up to C, then it's closer to D. But it also has to be below this perpendicular bisector between D and C going out to B. So this region down here is going to show all the points that are closer to D. And that'll be our green shaded area. Now we're left with this middle section. And what separated C from B was this perpendicular bisector that went up to point A and down to point D. So everything above and to the left is closer to C. So I'm going to shade this region in yellow. Those points are all closer to C. And finally, this last part that's in white, I'm going to shade in pink. And all the points in this pink region are going to be closest to vertex B. So this is how you can use perpendicular bisectors again to help you figure out when points are closer to one vertex or another. You simply make a perpendicular line, cutting your line segment in half at a 90-degree angle. Everything on one side is closer to one point. Everything on the other side is closer to the other point, and anything actually on the perpendicular bisector is the exact same distance. I hope this helps clear things up for you, but as always, if you still have questions, please feel free to leave a comment below. Practice problem number 4 is going to be the last practice problem for lesson 9, and also our last practice problem before the mid-unit 1 test. Which construction could be used to construct an isosceles triangle ABC given line segment AB? So before you can even attempt to answer this, you have to know what isosceles means. And this means two legs are the same length. So something that looks like this would be an isosceles triangle. So let's look at option A. Mark a third point C, not on the segment AB. Draw segments AC and BC. So let's try that. Let's draw a random line segment. We'll call this A and B. Let's do a random point C. And now if I draw segment AC, and then I draw segment BC, that does not create an isosceles triangle. Because if you're allowed to put point C just anywhere that's not on A or B, it doesn't necessarily create an isosceles triangle. So A would be incorrect. Option B, label a point C on segment AB. All right, well, let's give a random segment AB. Now we're going to label some random point on the segment as C. Construct a line perpendicular to AB through point C. All right, well, here is our perpendicular line. Draw segments AC and BC. Well, that just creates the original segment. So B is wrong. Option C. Construct the perpendicular bisector of segment AB. So here is AB. I construct the perpendicular bisector. Mark the intersection of this line and AB, this point right here in the middle, and label it C. Draw segments AC and BC. Again, that just creates the original segment. So C is wrong. So now we're down to option D. Construct the perpendicular bisector of segment AB. So here's segment AB. I construct the perpendicular bisector. Mark any point C on the perpendicular bisector except where it intersects AB. So I could put a point up here at the top. Draw segments AC and BC. Well, here's AC. Here's BC. And now, because any point on the perpendicular bisector is the same distance from A as it is B, then anywhere I put this point other than the point where it crosses, I'm going to have leg AC equal leg BC, which creates an isosceles triangle. I hope this has made sense for you. Not just this question, but all four of them. But as always, if you still have questions, please feel free to engage with a comment below. Now, before we finish the video, let's go back, review the learning targets, and ensure you understand everything you need to in order to be ready for that mid-Unit 1 test. Looking back on our learning targets for Lesson 9, we had two of them. Number 1, says that you can construct perpendicular bisectors to help solve problems. So the main things you have to remember is that a perpendicular bisector cuts a line segment exactly in half. It does so at exactly a 90-degree angle. And then because of that, everything on one side of the bisector is going to be closer to the end point on that side. Everything on the other side of the bisector is going to be closer to the end point on the other side. And then anything that is actually exactly on that bisector is the same exact distance from both endpoints. Learning target number 2 says that you can use your geometry knowledge to solve problems. So your knowledge of the shapes, your knowledge of a perpendicular bisector and what it does, and just general spatial awareness and being able to put together all of these different thoughts to find the answers to problems, just like we did in the practice problems. I hope you found this video helpful. If you did, in the bottom left of your screen, you'll see another video that YouTube is recommending. In the bottom right of the screen, you'll see a subscribe button for the channel. Please subscribe and help this channel grow. Leave a thumbs up for the video if you liked it. And as always, engage with a comment below. I look forward to seeing you in the next lesson. And good luck on the Mid-Unit 1 test.